Two rattlesnakes intertwine, not in a fight but in one of nature's most complex rituals. Their muscles move with precision, guided by codes older than memory itself. Why would they risk venom, energy, and exposure just to reproduce? The answer lies in chemistry. Every scent, vibration, and movement is part of a molecular negotiation, a dialogue written in pheromones and decoded by the Jacobson's organ. What we see as passion is a biological contract, signed for survival. In this rare footage, science reveals that rattlesnake mating isn't random, it's strategic. A biochemical dance where instinct meets evolution and desire becomes given. The question is, what makes a female choose one male over another? Across North America, from dry deserts to humid grasslands, rattlesnakes dominate the landscape. Among them, species like Crotalus atrox and Crotalus adamantius stand as icons of adaptation. Each region sculpts its own version. Thicker scales for heat, paler tones for camouflage, denser muscles for endurance. But behind their survival lies rhythm. Temperature and daylight act like biological clocks, signaling the arrival of mating season. When soil warms and prey returns, instincts awaken. What seems like chaos is actually perfect timing. Evolution's calendar reminding every rattlesnake that reproduction is not choice. It's command. Females release invisible trails of chemistry across the ground. Within these trails are pheromones, molecules that speak the language of fertility. Males detect them using the Jacobson's organ, a sensory radar inside the mouth that interprets chemical codes. A flick of the tongue collects information the eyes could never see: age, readiness, and even genetic compatibility. It's not smell as we know it. It's a biological vision system, an ancient network of data transfer. To a rattlesnake, the desert is not silent. It's filled with invisible messages guiding each step toward reproduction. But scent alone isn't enough. Inside both male and female bodies, hormones act as silent engineers. Rising temperatures trigger testosterone in males and estrogen in females, synchronizing readiness with environment. The process ensures that when two snakes meet, their internal chemistry is already aligned. It's precision without awareness, nature's version of programming. Scientists discovered that even slight climate changes can shift this timing, delaying or accelerating the entire season. In a way, the planet itself decides when rattlesnakes will fall in love. When conditions align, warmth, humidity, hormone balance, the desert transforms into a stage of invisible energy. Males begin to travel, tracing scent trails left hours before, sometimes following them for miles. Each movement is guided by data, not instinct alone. Through chemistry, physics, and timing, two creatures find each other in the vastness of the wild. This is not random encounter. It's biological precision, evolution operating like a coded system. The meeting between two rattlesnakes is not luck. It's the universe executing an ancient algorithm written in scales and scent. When two male rattlesnakes find the same female, the desert falls silent. They rise, coil, and begin what looks like a deadly confrontation. But this is no true fight. It's a ritual, an evolutionary choreography known as the combat dance. Each male tries to push the other to the ground, not with venom, but with strength and endurance. The goal isn't to kill, it's to dominate. They twist and sway, their bodies forming an organic spiral of tension and precision. Dust rises around them as they test muscle against muscle, patience against exhaustion. The one who resists longest earns the right to pass his genes forward. Nature doesn't reward aggression. It rewards control. Beneath the scales, every contraction is calculated. Muscles lock with astonishing precision, like living hydraulics engineered by evolution. Scientists studying this behavior discovered that during combat, heart rate and blood pressure reach extreme levels, sustained for minutes without fatigue. It's not just physical power. It's endurance, coordination, and discipline encoded into DNA. Each snake reads its opponent's movement, predicting the next twist, the next rise. What seems spontaneous is a biomechanical formula. Force equals survival. The female watches closely. She's not attracted to violence, but to the rhythm of persistence, the one who never breaks the pattern of control. While the males wrestle, the female remains still, motionless, but deeply perceptive. Her senses read more than sight. She feels vibration, pressure, and energy radiating through the ground. In this duel, she measures not who strikes hardest, but who lasts longest. It's evolution's audition for endurance. The victor isn't chosen by chance, but by biochemical signals sent through movement and vibration. The female's brain interprets this data like an algorithm, matching the winner's energy signature with her own hormonal state. In her stillness lies selection, a process older than emotion yet precise as any scientific method. When one male finally lowers his head and retreats, the ritual ends instantly. No blood, no bites, just silent acknowledgement. The victor approaches the female, his body still trembling with exertion. His scent now carries hormonal markers of dominance, a chemical message that signals victory. To her, this is proof of fitness, an invisible certificate of strength. The defeated male withdraws to recover, perhaps to challenge again another day. In the wild, failure is not shame, it's data. Each confrontation refines evolution's code, teaching the next generation which traits ensure survival and reproduction. The victorious male doesn't rush. He begins to follow the female, moving beside her for hours, sometimes days, synchronizing his rhythm to hers. Every movement aligns their body temperature. Every vibration communicates readiness. It's as if two separate systems are syncing through invisible waves, chemistry meeting choreography. The female's pheromones fluctuate as her body confirms his persistence. Mating will only occur once this balance is reached. The process looks primitive, but it's deeply mathematical. Evolution optimizing the equation of reproduction. In the world of rattlesnakes, love isn't random. It's algorithmic perfection hidden beneath scales and silence. After the ritual of dominance ends, silence takes over. The victorious male begins a slow pursuit, tracing the female's path like a shadow. Every flick of his tongue measures her chemistry, confirming that she's still receptive. This chase can last hours, sometimes days. He moves with precision, matching her rhythm, keeping a safe distance until she allows proximity. The desert becomes their stage, two bodies moving as one equation of heat and pheromones. He doesn't bite or strike, he follows, observes, waits. Every movement of her tail, every vibration on the sand is a signal he reads like code. This is not passion, it's programming, a synchronization of bodies engineered by evolution itself. As they move together, their bodies begin to align in more than motion. Temperature synchronization becomes critical. The male maintains constant contact, pressing his body along hers to detect the precise moment her muscles relax, a biological permission. When their thermal rhythms converge, he knows it's time. Scientists call this phenomenon thermal coupling, a process where the male senses minute shifts in the female's body heat, guided by his heat-sensing pits near the mouth. It's infrared intimacy, a biological conversation in temperature gradients. What looks like gentle persistence is actually scientific precision. Every degree matters, every pause carries meaning. When the moment arrives, connection begins, and so does the greatest risk. The male inserts one of his two hemipenes, locking the pair in a prolonged embrace. Nature adds a safeguard, the copulatory plug, a gelatinous substance that forms inside the female after mating. It acts as a biological seal, preventing other males from reproducing with her. Evolution once again designs exclusivity through chemistry, but this process renders them both vulnerable. Locked together, they can't flee predators. Every rustle in the grass becomes a threat. Reproduction in the wild is never safe. It's a gamble of genetics against survival. During mating, rattlesnakes abandon their natural defense patterns. They move less, hiss less, and their rattle, the symbol of warning, falls silent. In those hours, they are prey. Hawks, coyotes, and even humans become potential dangers. Yet this silence is crucial. Noise could draw predators and ruin the genetic transfer. It's an evolutionary paradox. Nature forces them to expose themselves at their most critical moment. Still, through thousands of generations, the species endures, proof that risk is not failure but necessity. Every offspring born is the result of two snakes that dared to stay still in a world that demands movement. When the process ends, the male slowly retreats, leaving behind his invisible mark. The copulatory plug ensures his genetic legacy, and the female, now fertilized, begins her next phase, storing the sperm deep within specialized organs. It's not immediate fertilization. She decides when it happens. For the male, his task is complete. For the female, it's just beginning. This system of delayed fertilization is one of nature's greatest evolutionary advantages, allowing her to wait for perfect environmental conditions. What looks like instinct is actually agency, evolution granting her control over time and survival. As the desert cools, both snakes part ways. The male, exhausted, disappears into shadow. The female remains motionless, conserving energy, her body processing the hormonal storm of the encounter. Inside her, millions of cells await a signal, a future decision she alone will make. This is the confrontation nature hides, not between bodies, but between biology and destiny. Every heartbeat echoes an equation, reproduction balanced against survival. What seems like love, conflict, or risk is simply nature executing its most perfect algorithm. Life continuing through precision, patience, and silence. Inside the female rattlesnake, the act of mating is just the beginning. Once the male departs, a silent chemical orchestra begins. Hormones surge, estrogen, progesterone, and specialized peptides flood her bloodstream. These signals instruct her body to either activate or preserve the sperm now stored within. Scientists discovered that in many rattlesnake species, fertilization doesn't happen immediately. Instead, sperm can remain viable inside her for months, sometimes nearly a year. It's evolution's insurance policy, giving her time to wait for the perfect moment, when heat, humidity, and prey availability align with survival. Deep within her oviducts, microscopic structures called sperm storage tubules act as living vaults. Each chamber preserves sperm cells in a state of suspended animation, maintaining their energy and DNA integrity through controlled temperature and chemical balance. The female's immune system, which would normally attack foreign cells, is subdued by hormonal regulation. It's a biological truce, her body agreeing to host another's genetic code until the environment signals readiness. Evolution engineered her as both guardian and gatekeeper of the species' future. What triggers fertilization is not chance. It's temperature. When ambient and internal body temperatures reach a specific range, the stored sperm awaken. Their metabolism restarts, guided by subtle hormonal cues. It's as if her body reads the desert, waiting for equilibrium between climate and survival. This process is known as thermoregulatory fertility control. In simple terms, she won't risk creating life in instability. Evolution, through her, calculates the probability of success. And when that probability rises high enough, life begins. When fertilization finally occurs, it's not random mixing. The female's body selectively activates certain sperm, preferring those with stronger motility or chemical compatibility. This hidden selection ensures only the fittest genes contribute to the next generation. Scientists call it cryptic female choice, an invisible filter of evolution. It's proof that natural selection doesn't end with combat. It continues inside her body. In this silent phase, she becomes nature's editor, fine-tuning the blueprint of life before it ever begins to form. Once fertilized, the embryos begin developing inside her. Not in eggs laid externally, but within her body, a process known as ovoviviparity. The young grow protected, feeding off yolk reserves rather than a placenta. Her body temperature becomes their incubator, and her stillness their safety. Even now, she retains the power to pause development if conditions deteriorate, an ability called facultative embryonic diapause. It's biology's pause button, letting her freeze time until survival is possible again. Evolution doesn't gamble, it plans. Inside her bloodstream, a network of chemical messengers orchestrates everything. Estrogen promotes follicle growth, progesterone sustains sperm viability, and a lesser-known hormone, prostaglandin, regulates contractions during fertilization. Each substance has perfect timing, milliseconds of release that determine the success of reproduction. Any imbalance can mean failure. Scientists studying this phenomenon compare it to a biological operating system, capable of adjusting itself to external variables. Unlike human design, nature doesn't need correction. It evolved perfection through repetition. The stored sperm face harsh conditions, fluctuating temperatures, dehydration, and oxidation. To survive, they rely on antioxidant enzymes secreted by the female's own cells. Molecules like catalase and superoxide, dismutase neutralize oxidative stress, preventing DNA damage. In essence, she acts as a living cryogenic chamber. Researchers believe this adaptation evolved over millions of years to ensure continuity, even in unpredictable climates. It's a reminder that what we call instinct is often molecular intelligence. Each reproductive cycle operates in harmony with external cues, barometric pressure, rainfall, and even lunar phases. Studies show that rattlesnakes adjust mating and birthing periods to coincide with peak prey abundance and mild temperatures. Their bodies sense environmental change like living sensors, aligning physiology with ecology. This synchronization transforms reproduction from instinct to algorithm. The desert and the snake are no longer separate. They're one connected system, exchanging data through chemistry and climate. Months may pass without visible change, but inside her, life is waiting. Every heartbeat maintains the fragile equilibrium between growth and dormancy. When the conditions finally align, warm soil, humid air, abundance of prey, the stored sperm awaken, and embryos resume development. It's the slowest yet most efficient reproductive strategy nature could design. She has mastered time itself. The female rattlesnake doesn't just reproduce, she calculates survival, ensuring every birth is an act of precision, not chance. What science uncovers here is more than instinct. It's evolutionary engineering. The female rattlesnake embodies adaptability at a molecular scale. She controls not only when life begins, but when it should wait. Her body functions as both laboratory and sanctuary, balancing chemistry, physics, and biology to perfection. It's a design beyond intelligence, born from millions of years of trial and refinement. While humans manipulate time with machines, nature already did it with cells. The invisible science of reproduction proves that evolution doesn't just create life, it optimizes it. In the record books of evolution, few rituals last as long as a rattlesnake's union. Some pairs remain intertwined for over 24 hours, a full day of endurance and stillness. During this time, both snakes lose water, body heat, and energy, yet they persist. It's an evolutionary marathon, testing patience as much as biology. Scientists believe this prolonged contact enhances fertilization success and secures the male's genetic dominance. In a world driven by instinct, persistence becomes strategy. The slow dance of DNA performed in silence beneath the sun. Even after separation, sperm cells stored inside the female can stay alive for months, sometimes beyond a year. One of nature's longest biological preservations. Their membranes resist oxidation. Their DNA remains intact. It's a level of durability rivaling advanced cryogenic techniques in human science. Through this adaptation, evolution gives the female command over the future. She can wait for a season of abundance before creating life. What we see as delay is actually design, a living system mastering time far before humans ever tried. Not all rattlesnakes follow the same reproductive rhythm. Desert species like Crotalus cerastes evolve thicker scales to reduce water loss during mating, while forest dwellers such as Crotalus horridus synchronize reproduction with rainfall and prey migration. Genetics shape geography, and geography refines genetics. Each population writes its own version of survival, adapting behavior to ecosystem. This is evolution in real time, not fossils, but living algorithms recalculating the formula for success with every generation. Some females play evolution's oldest trick: deception. They release false pheromones that lure males away from rivals, forcing competitors to waste energy chasing illusions. It's a molecular manipulation as ancient as life itself. Through this, the female increases her own survival odds and protects her offspring's lineage. To human eyes, it's cunning. To biology, it's strategy. Evolution doesn't play fair, and it plays efficient. In the chemistry of life, even deceit becomes part of design. In the rattlesnake's world, what seems violent or random is actually order, a symphony of chemistry and instinct. From the first click of the tongue to the final pulse of fertilization, every step follows a formula older than mountains. Evolution doesn't improvise. It calculates. Every battle, every risk, and every moment of stillness serves a single purpose: to preserve the code of life. Beneath the scales and the silence, nature hides a logic so perfect it seems almost designed. The desert doesn't create chaos. It creates precision. Every choice a rattlesnake makes, when to fight, when to follow, when to reproduce, is decided not by will, but by molecules. Hormones, pheromones, and neural patterns dictate a choreography older than consciousness. What we interpret as instinct is actually the execution of biological equations. Life operates like a computer made of cells, processing chemistry into destiny. When science observes these patterns, it doesn't just study snakes, it studies the source code of evolution itself. Desire, dominance, deception, These are not emotions, but survival algorithms. The patience of the female, the persistence of the male, the risk both take. All this is proof that nature's most complex stories unfold silently. What we call love or attraction is simply the language of continuity. Every scent, vibration, and movement is data, passed down from generation to generation. And in these data lies the deepest truth. Nature seeks not beauty or passion, only balance. In the world of rattlesnakes, love is chemistry, literally. Every heartbeat, every breath, every choice follows the invisible mathematics of life. From combat to conception, nothing is accidental. What we witness is not cruelty or chaos, but design. Evolution sculpting perfection through trial and time. If you're fascinated by nature's hidden systems, subscribe to our channel, like this video, and keep watching until the next discovery.